This lesson is titled Synthetic Division, Remainder Theorem, and Factor Theorem. We're going to start with synthetic division, but before we do, I want to remind you of some terms that we'll be using throughout this lesson, and I want to make sure that you remember some of these terms. Okay, recall that when you divide, you take a dividend and you're dividing it by a divisor. The result is called the quotient, and you'll have sometimes a remainder over the original divisor if we have any leftover remaining parts. If you long divide using a long division bar, your dividend goes on the inside, your divisor goes on the outside, your quotient is the answer part that remains at the top, and after you do all of the work, you might end up with a remainder down here. And that remainder is just going to go over the divisor when you write your answer. So let's just do a simple question. If I take 35 and try to divide it by 4, the 35 is the dividend, it goes on the inside. The 4 is the divisor, it goes on the outside. And 4 goes into 35 8 times, and 8 times 4 is 32. I'm left over with a remainder of 3. Notice there's nothing else I can bring down. I could put a decimal, but when we're going to be applying this towards polynomials, there won't be a decimal in polynomials. That just doesn't really make much sense. So our 8 is the quotient. The 35 was the dividend. The 4 is the divisor. And our 3 is the remainder. So 35 divided by 4 is equal to 8 plus 3 parts left over out of the original divisor, 4. Now you may be thinking, hey, we never write 8 plus 3/4. That plus we just kind of eliminate altogether. We usually write 8 and 3/4. But even when I said that, 8 and 3/4, we say the word and the and is that addition sign right there. So we do say 8 and 3/4, which means we're taking 8 wholes and also 3/4. So there's an implied plus sign here. You will need to be using the plus sign because we'll be using polynomials, and so this plus sign is really going to be used. In beginning algebra, you learned how to long divide polynomials. It was very long, there was a lot of steps to it, and often students made some mistakes. So what we're going to be showing you instead is a shorter method called synthetic division. Synthetic division of polynomials is a condensed division method. Our divisor must be in the form x minus c, linear term with the leading coefficient being 1, where c is a real number, in order to perform synthetic division. Using long division, which we learned at beginning algebra, the divisor did not have to be in this form, but it will have to be in the form if we're using synthetic division. And we're going to be manipulating all of our polynomials so that we are only dividing by x minus c as a divisor, so that we can use the shorter method synthetic division. Today's lesson, we're basically just learning how to use synthetic division and learning about 2 more theorems. We're going to take this information and apply it in our next section. Let's just look at one long divide problem and show you how the synthetic division will be a little bit easier. So let's say I'm having x cubed plus 5x squared plus 7x plus 2 is my dividend, so it goes on the inside. And you're probably going to want to write small here. X plus 2 is my divisor. Notice that the x minus 2 is in the form the linear form, x minus c, where the leading coefficient is 1 and it's a linear term. So this will qualify for synthetic division. But I'm going to show you long division once so that you remember how to do it, and then we remember that it might not be the fastest method. So the first thing we're going to do is we're going to take the polynomial and try to divide it by the divisor. Well, I can't do that. I don't know what this whole dividend divided by the divisor is. So I'm just going to take the first term divided by the first term. So x cubed divided by x. And that's going to get me x squared. And we're going to put that up at the top where the quotient belongs. I like putting the x squared in the x squared column. Everything should be nice and neat lined up. X cubes are in the first column, x squares are in the second, x's are in the thirds, and numbers will be the last. Then I'm going to multiply back through x squared times x, getting x cubed plus 2x squared. Next I have to change all the signs, or subtract. And instead of subtracting, I like to change the signs to remind you that you're subtracting both terms. X cubed minus x cubed is 0. And that's supposed to happen. If that doesn't happen, then you probably didn't pick your quotient correctly. 5x squared minus 2x squared is 3x squared. We're going to drop down the 7x and repeat. I can't take 3x squared plus 7x and divide it by x plus 2. I just don't know how to do that. So instead, I'm going to take the first term divided by the first term. And that'll be enough information for me to at least get to my next step. So 3x squared divided by x gets me 3x. And I'm going to put that in the x column. Notice that the 3x is above the 7x, which is above the 7x. Multiplying back through, I'm getting 3x times x, or 3x squared. 3x times 2 is 6x. Notice everything is in the right columns. Now I'm going to subtract. But instead of subtract, I'm going to change both of their signs. I want to subtract both the first term and the second term. 3x squared minus 3x squared goes away, like it should. 7x minus 6x is 1x. Drop down the last term and repeat. Again, I'm taking the first term divided by the first term. X divided by x is just plain 1. But we kind of knew at this point that it should have been a number because it has to be in the number column. So if my first one was x squared, then the next one really should have been an x, and the next one really after that should be a constant term. So once you have the first couple of x's in the right spot, all the rest of the x's should be following in their column order. When I multiply back through, I'm getting x. 1 times x is x. 1 times 2 is 2. And then I change both of the signs, and I'm getting a remainder of 0, which means I don't have to write 0 over x plus 2, because that's just a little bit redundant. No one writes plus 0, do we? So I'm just going to erase that. We don't really write that. Although technically it could be there. So, therefore, the dividend divided by the divisor is equal to x squared plus 3x plus 1. And I've answered the question. Unfortunately, this was very long. It was a long process. It was some students might say it was hard. I'll go ahead with boring because it takes a really long time to get all this done, and there's lots of room for errors. Okay? So not necessarily the best method, although it will work. And not only will it work, but it will work for any divisor and not just the linear divisors with coefficient 1. So what we're going to do here is show you a different method, synthetic division, or synthetically divide, which is a division method. It's a condensed division method, okay? Condensed. So this means it should be a little bit shorter. Hopefully we're going to make it a little more fun, and there'll be less room for errors, especially with the subtracting and the changing the sign and the multiplying. A lot of students will confuse on long division when to multiply and when to subtract and whatnot. So synthetic division is a little bit shorter. So what we're going to do is we're first going to look at the divisor, x plus 2. Now all of the divisors have to be of the form x minus c in order for synthetic division to actually work. So if my divisor is x plus 2, notice there's a minus in the c, x minus c, so the x minus would be x minus a negative 2. This is going to be the opposite value is going to go in this little division bar here. Because essentially when you multiply back through, the x was always just 1x. It's just the second one that actually changed up all the numbers. So we're only really going to be focusing on the 2 because the first one will always be x, and that won't change. The other thing that we're going to be doing for synthetic division is we're going to be taking out the x's. I know that the first column is always going to be x cubed. I know that the second column is always going to be x squared. The third is always going to be x, and the fourth column is always going to be number. So what is the point in writing x's all over the place? If I could just keep everything in their columns, then I will have all the answers, and then I can just stick the x's back in at the end. Notice that after you take an x cubed and divide it by x, my answer was x squared. So my answer I know is going to be 1 less than the original dividend. So I am only going to be focusing on the coefficients, or the numbers in front, instead of the letters or the variables. So my coefficients here are 1 in front of the x cubed, 5 in front of the x squared, 7 in front of the x, and the constant is 2. So I'm really just using the coefficients. My first thing I'm going to do is I'm going to bring down the 1, and the reason I'm allowed to just bring down the 1 is because there's a 1 in front of the x. Notice when I divided by the first term divided by the first term, every time I did that I'm only dividing by 1x, and so I really didn't change. 3x squared divided by x is on 3x, so because I'm always dividing by the first term, I really don't need to do that hard division. All I need to do is just take the exponent down by 1, which is what I'll do at the end. Next, after I did the 1, then I multiplied back through, right? So once I found the 1x squared, which is the 1 right here, I multiplied back through. I got x cubed and 2x squared. So I'm multiplying. So 1 times negative 2 is negative 2. Notice that I did not have to change the sign. It was already a negative 2. Remember when I changed the sign? But because I changed the sign here, I didn't need to change the sign every single other time. So when I multiply, that's already the correct sign. So the next thing I need to do is add down, and that's what I'll do. 5 plus a negative 2 is positive 3. That's the 3 that came right there. When you divide 3x squared divided by x, you just got 3x. Remember, that number didn't really change, it just dropped the exponent by 1. So then we have the 3x up here, and when I multiply back through, I'm getting negative 6. Notice that's the negative 6 right there. When I add down, I'm getting 1. And that's the one that I have right here, 1x. Then I took 1x divided by 1x, and I just got the constant 1. Next, I took the positive 1 and multiplied it by x plus 2, and I got a negative 2. That negative 2 is the same negative 2 we have right here. Notice I didn't have to change the sign because I already changed the sign once. I didn't have to change it every single step. I just changed it once in the beginning, and then I won't have to change it again at all. Lastly, I'm getting an answer of 0. So let's take this information and interpret it. We've noticed that the same numbers appeared at the end. Our answer is the same answer up here as long as we drop the exponents by 1. This will get me 1x, this was an x cubed, but now I'm going to drop it to x squared, plus this was an x squared, I'm dropping down to 3x. This was the x column, I'm going to drop it down to a constant. And this was the constant term, but now this is going to be my remainder. So the answer was truly the same answer that we got up here. I know that you may not have understood exactly how everything came from synthetically division from long division, but I wanted you to at least see them side by side and show you that they do come out to the same answer and that they do have the same numbers appear. It's just without all the x's and without all the changing of signs. You only change the sign once in the beginning instead of changing it every single time. Next, I'd like to show you how to do synthetic division while writing out the steps so that you can go back and refer to the steps one more time. So our steps is, first I want you to identify the divisor C, which is the opposite number with the x in the denominator. Okay, so looking at this, we have a linear term here, leading coefficient of 1, so this does classify as a synthetic division problem. My divisor, or my C, will be the opposite of the number in the divisor that's with the x. So my divisor is going to be 2, and I'm going to put that in the little division bar, which is step 2. Put the C in the division bar and list all of the coefficients of the dividend, which is the numerator. So I'm going to list 5, leave a little space 6, leave a little space 3, and negative 10. I want you to leave one line of space here and then put a bar. And we're going to be working down here. Within this step, it says be sure to account for any missing terms. So if you don't have an x cubed term, or if you don't have an x squared term, you're going to need to put a 0 there, and I'll show you an example of that in a little bit. Next, I want you to bring down the first coefficient in the dividend, which in this case is going to be 5. I want you to multiply this number by C, which is the divisor. 5 times 2 is 10, and that's step 4. Place this product underneath the next coefficient. Notice I placed it in the next column underneath the next coefficient. Step 5 says to add down. So when I add down, I get 4. And then the last step says repeat steps 4 and 5 until you run out of columns. So I'm going to multiply 4 times 2 again to get 8. I put it in the next column over underneath the next coefficient. Add down, get 11. Multiply 11 times 2 and get 22. Add down, you get 12. So really it's multiply, add, multiply, add, multiply, add. As long as you've set up the original divisor correctly, taking the opposite sign, using all the coefficients, all you have to do is multiply and then add down. Multiply the divisor, then add down, so on and so forth. Note that the quotient, which is the answer for the division, will begin 1 degree less than your dividend. The numbers obtained in the last row here will be the coefficients of your answer. So let's go back and answer the actual question. I was taking a dividend 5x cubed minus 6x squared plus 3x minus 10 and dividing it by x minus 2. My answer will be 5, this was the x cubed column, so I'm going to drop it by 1, 5x squared, plus this was the x squared column, I drop it by 1, 4x, this was the x column, I'm going to drop it by 1, and now this becomes my constant. This was my constant term column, so now this is going to be my remainder. And the way we write our remainder is 12 over x minus 2. So that is our final answer for this division problem using synthetic division. It may seem a little complicated, and we're going to do a lot of more examples, but it is a whole lot faster than some of the other methods we could have used.